There are moments in human history when the very ground beneath our feet shifts, when the universe, in its infinite silent wisdom, sends us a message that shatters our comfortable assumptions. This is one of those moments. For millennia, we have looked to the stars and seen reflections of ourselves, our gods, our myths, our future. We drew lines between them, creating order in the chaos, believing we understood the boundaries of our cosmic neighborhood. We were wrong. Imagine, if you will, the Atacama Desert at dusk. The air, crisp and thin, shimmers with the last vestiges of daylight, painting the rugged landscape in hues of orange and purple. Above, the sky begins its nightly transformation, deepening into an impossibly clear canvas where stars, unburdened by city lights, emerge in a dazzling ancient tapestry. In this profound isolation, stark white domes stand sentinel, monuments to human curiosity. 1. The Atlas Observatory in Chile gleams under the nascent starlight, a silent sentinel with an urgent purpose. Ambient desert sounds, the whisper of wind, the distant cry of a nocturnal creature, weave into a low, anticipatory musical score. This is where our story begins. For as long as we have been human, we have looked to the stars and seen reflections of ourselves, our gods, our myths, our future. We drew lines between them, creating order in the chaos. We thought we knew the neighborhood. We were wrong. This is the story of a visitor, not a guest we invited, but a traveler on a journey so long, it defies comprehension. A journey that began long before we existed, in a place we may never see. And its brief passage through our home would challenge everything we thought we knew about our place in the cosmos. Our solar system, you see, is not an isolated island in the vast cosmic ocean. It is a shoreline, a sunlit beach where the ceaseless tides of interstellar space occasionally wash ashore something truly extraordinary. For millennia, our astronomical observations were akin to studying only the local wildlife, the planets, asteroids, and comets that are gravitationally bound to our sun, familiar inhabitants of our celestial backyard. We knew their paths, their rhythms, their stories. But every so often, the cosmic ocean delivers something utterly alien, a piece of driftwood, so perfectly preserved and distinct that it could only have come from a distant, unknown continent, carried across unimaginable depths, and for only the third time in recorded history, that moment arrived. This is the story of Three-Eye Atlas, a messenger from the void, a whisper from the interstellar deep. The date was July the 1st, 2025. Cut to the interior of the Atlas control room. It's a scene of focused professionalism. Screens display cascading data, algorithms silently sifting through countless points of light, searching for anomalies. We meet the astronomers on duty, dedicated, focused individuals whose days and nights are spent deciphering the universe's subtle clues. The low hum of computers, the gentle clicking of keyboards, form a rhythmic backdrop to their tireless vigil. The music, previously anticipatory, now adopts a more inquisitive, simple piano motif, mirroring the unfolding intellectual drama. An automated alert flashes on a primary display. A routine flag, perhaps. A fast-moving object, an unusual trajectory. Nothing out of the ordinary at first glance. These systems are designed to spot many such curiosities every night. But then, a closer look. Close-ups on the astronomers' faces reveal a subtle shift. Initial routine curiosity gives way to intense focus, then to quiet disbelief. Their eyes narrow, brows furrow, fingers hover over keyboards, rerunning the numbers, inputting new parameters. You feel the tension in the room, the silent communication of trained minds grappling with an unexpected pattern. You hear snippets of dialogue, hushed at first, then laced with a growing sense of wonder. That can't be right. Run the orbital again. The voice is steady, but the tremor of suppressed excitement is palpable. Look at the eccentricity. It's over 1. This single technical phrase carries the weight of momentous discovery. An eccentricity greater than 1 means one thing. The orbit isn't an ellipse, it's a hyperbola. The object isn't looping back, it's just passing through. It's not one of ours. My God, it's interstellar. The words hang in the air, a profound realization settling upon the team. This is the moment the mundane becomes momentous, when the routine work of planetary defense transmutes into an encounter with the truly cosmic. On July 1st, 2025, a robotic eye, designed to protect us from threats originating within our own solar system, found something else entirely. Not a threat, but a mystery. A faint smudge of light, designated 3I Atlas, moving too fast, on a path that could only mean one thing. It had come from the void between the stars. The news, as it always does when fundamental assumptions are challenged, spread like wildfire. A montage sequence begins, mirroring the rapid dissemination of this extraordinary discovery. An official minor planet electronic circular alert flashes across the screen, the scientific community's digital beacon announcing a new celestial body. Then, a flurry of news headlines from around the world, in different languages, on different platforms, all grappling with the same astonishing fact. A third visitor from beyond our sun's gravitational embrace. Animated graphics depict the hyperbolic trajectory of 3I Atlas. A clean, sharp arc slicing through the familiar plane of our solar system, an arrow pointing to an origin far, far away. We see quick shots of other observatories, their giant dishes and gleaming domes across continents, swiftly turning their collective gaze towards this new, fleeting enigma. The scientific community, primed by previous encounters, is buzzing with an electrifying mix of excitement and urgent purpose. A crescendo in the music accompanies the montage, amplifying the sense of global attention. Mixes of news reports in different languages overlap, each voice carrying the same astonishing message. Interview soundbites from excited astronomers, their faces alight with discovery, express the profound significance of this new arrival. A third interstellar object, one exclaims. A third whisper from the void. Another adds, and this time, we were ready. The questions that lingered, tantalizing and unanswered, from our first fleeting encounters with Oumuamua and Borisov, were now front and center, given renewed urgency and depth by the arrival of 3I Atlas. What are these objects? Where do they truly come from? And what secrets do they carry from their unimaginably long journey through the dark, silent expanse between the stars? You see, Oumuamua, discovered in 2017, was the first. It was a strange cigar-shaped enigma, moving with a tumble that defied easy explanation, sparking a fervent debate about its true nature. Then came Borisov in 2019, clearly a comet, but still a stunning confirmation that interstellar objects were not just theoretical constructs, but tangible realities. Each offered a fleeting glimpse, a whisper. But 3I Atlas, arriving just a few years later, solidified the realization that these aren't isolated anomalies, but rather a rare yet recurring phenomenon. We are truly on a cosmic shoreline, and the ocean is vast. The sheer rarity of 3I Atlas makes it a captivating subject, a tangible connection to star systems beyond our own. It is a messenger, not just of matter, but of profound possibility. Imagine for a moment the journey this object has undertaken. It could have been flung from a distant star system billions of years ago. A cosmic refugee ejected from its birth star by a gravitational slingshot, or perhaps the chaotic dance of a binary system. It could be a relic, far older than our own sun, carrying the dust and ice from the earliest days of our galaxy's formation. The very idea that 3i Atlas could be an ancient artifact, potentially predating our own solar system by as much as 7 billion years, is mind-bending. If it originated from the Milky Way's thick disk, a region populated by some of our galaxy's most ancient stars, then this object isn't just a rock, it's a time capsule, a piece of cosmic archaeology offering clues to the early universe itself. This incredible age, this potential genesis in a primordial corner of our galaxy, makes its passage through our solar system not just a scientific event, but a philosophical one. It challenges our temporal perspective, forcing us to consider existence on scales that dwarf human comprehension. You are looking at something that has traversed the void for eons, a silent witness to countless stellar births and deaths, a fragment of a universe far older than anything we have ever held in our hands. But 3i Atlas is not just old, it is also profoundly enigmatic. From the moment of its discovery, it has exhibited several puzzling characteristics that have fueled the scientific community's curiosity and created a compelling narrative hook. One of the most striking observations was a sudden, inexplicable brightening as it neared the sun. Most comets brighten as they approach our star, as their volatile ices sublimate and form a glowing coma. But 3i Atlas's surge was unexpected, a dramatic increase in luminosity that hinted at processes yet to be fully understood. Then came the observation of a distinct blue color shift as it continued its journey closer to our sun. Blue comets are rare, and this particular hue hinted at a unique chemical composition, or perhaps an unusual interaction with solar radiation, unlike anything we'd seen before from an interstellar visitor. Adding to the mystery, astronomers detected nickel vapor at a surprisingly large distance from the sun, a distance where the heat should not have been sufficient to vaporize nickel. This anomaly suggested either an incredibly volatile composition or some unknown mechanism at play, perhaps even internal heating. These unexplained behaviors transform 3i Atlas from a mere celestial body into a cosmic detective story, each anomaly a clue in a grand interstellar mystery. The very fact that 3i Atlas is on a hyperbolic trajectory means it will never return to our solar system. This fleeting glimpse, this time passage, creates an immense sense of urgency and makes every observation precious, every data point a dramatic capture against the backdrop of its inevitable departure. It's like a ship passing in the night, a brief flash of light on the horizon before it sails back into the boundless dark. And then there's the controversy, the involvement of Harvard astronomer Avi Loeb, who has publicly speculated that 3i Atlas, much like Oumuamua before it, could be of artificial origin, introduces a compelling element of scientific debate and a touch of science fiction into the narrative. His arguments, while outside the mainstream scientific consensus, force us to confront the boundaries of our understanding. Is it truly just a natural object, albeit an unusual one? Or is there something more? This debate, regardless of its ultimate scientific merit, is a powerful driver of public interest, inviting us to consider the most profound questions of all. Are we alone? It's crucial, however, to clarify what we mean by interstellar. This simply means between stars. It refers to the origin of the object, not necessarily its composition or intelligence. 3i Atlas is a natural phenomenon, albeit a rare one, a cosmic wanderer ejected from another star system. It is vital to distinguish this from being extraterrestrial in the sense of intelligent life, though the presence of anomalous chemical signatures or unusual behavior naturally prompts such questions. Furthermore, we must repeatedly emphasize that 3i Atlas poses absolutely no danger to our planet. Its closest approach is still hundreds of millions of kilometers away, a vast, safe distance. This visitor is a scientific marvel, not a threat, and understanding this is key to appreciating the wonder of its journey without fear-mongering. Finally, the story of 3I Atlas is a harbinger of things to come. Future observatories, like the Vera C. Rubin Observatory, with its unparalleled survey capabilities, are expected to discover many more interstellar objects in the coming years. This positions the 3I Atlas story not as an isolated singular event, but as the dawn of a new era of interstellar astronomy, a time when our cosmic shoreline will be bustling with whispers from the void. What profound new questions will these future visitors pose? What profound new questions will these future visitors pose? The universe whispers to us, not always in grand pronouncements, but sometimes in the silent passage of a solitary wanderer. Today, that whisper arrives in the form of 3I Atlas. Discovered on July 1st, 2025, by the Atlas Survey Telescope in Chile. This object is more than a mere rock. It is a time capsule from the dawn of the Milky Way, carrying the chemical fingerprints of a star system that may have died billions of years ago. It is a piece of cosmic archaeology, a tangible link to an otherwise inaccessible past. Imagine, if you will, being an archaeologist, unearthing a single ancient shard of pottery from a deep layer of earth. This isn't just a broken piece of clay. It's a fragment imbued with history. By meticulously studying its composition, its color, its structure, you aren't merely learning about the shard itself. No, you are trying to reconstruct the entire vase, to envision the workshop that made it, and to understand the long-vanished culture that once used it. This single shard is a window into a world long gone. In much the same way, scientists today are cosmic archaeologists, and 3I Atlas is our single ancient shard. The initial spectrographic analysis of the 3I Atlas yielded results that were, quite frankly, bizarre. The chemical ratios were unlike anything seen in our own solar system. But it was the isotopic composition that truly stunned the scientific community, pointing to an incredible age, potentially 7 billion years old. This object is not just from another star, it is from another time, a relic that may predate our own sun and Earth by billions of years. It is, in essence, a fossil from the galactic dawn, preserving information about conditions that existed long before our star was even born. As we contemplate such an ancient traveler, let's define this visitor. Imagine stunning, scientifically accurate CGI, where we fly alongside 3I Atlas. It appears as a dark, irregular object, silently tumbling through the vast, indifferent expanse of space. Data visualizations overlay the screen, meticulously explaining its trajectory. An expert, with a calm and clear voice, uses a relatable analogy to explain why its incredible speed prevents it from being captured by the sun's gravity. Think of a marble rolling across a stretched rubber sheet, representing the fabric of space-time warped by the sun's mass. If that marble rolls too fast, it won't spiral inward. It will simply curve around and escape, launched back into the void. That is the essence of a hyperbolic trajectory, an orbit with an eccentricity greater than 1, meaning the object has enough velocity to escape the central body's gravitational field. This awe-inspiring visual journey is accompanied by an orchestral score, building a sense of profound wonder. An expert planetary scientist then clarifies, to truly understand 3I Atlas, we must first understand what it is not. It is not a spaceship on a mission, nor is it a deliberate emissary. It is a castaway, a cosmic orphan. It was likely thrown from its home star system by a violent gravitational wrestling match, perhaps between giant planets in its birth system. Such gravitational interactions can fling smaller bodies, like planetesimals, out of their system and into interstellar space. For unimaginable eons, it has wandered the interstellar wilderness, a silent witness to galactic history. This isn't our first encounter with such a wanderer. Our first confirmed interstellar visitor, Oumuamua, was a ghost that came and went so quickly, leaving behind far more questions than answers. Archival footage and graphics of Oumuamua remind us of its bizarre, cigar-shaped artist impressions, its highly elongated form, unlike anything seen in our solar system. We recall the graphs showing its strange, non-gravitational acceleration, a mystery that baffled scientists. Oumuamua was small, dark, and its acceleration couldn't be fully explained by gravity alone, sparking intense controversy and even speculation. It was the dress rehearsal, forcing the scientific community to develop new models and to be prepared for the unexpected, recognizing that interstellar visitors should be more common than previously thought. The music shifts, becoming more mysterious and questioning, reflecting the lingering enigmas of Oumuamua. With 3 Sayatlas, the scientific community was determined not to miss a single clue. Unlocking the secrets of this ancient time capsule demanded meticulous observation. We go inside a major observatory, perhaps the Very Large Telescope, VLT, in Chile, or the Keck Observatory in Hawaii. The quiet hum of the observatory is almost meditative, a stark contrast to the colossal power of the instruments at work. We see scientists, eyes glued to screens, analyzing the faint light from the comet. Animated graphics beautifully illustrate how spectroscopy works, a technique that uses the interaction between light and matter to gather information. Light, the ultimate messenger, passes through a prism, breaking into a rainbow of colors. But this isn't just a pretty spectrum. It's a cosmic barcode. Dark lines, known as absorption spectra, appear where specific colors are missing. Each line is a unique chemical fingerprint, revealing the elements and molecules present in the object's coma and surface. The light from 3I Atlas, though faint, is a treasure trove of information, a letter that has been in transit for billions of years. By decoding this light, astronomers can read its chemical composition, its temperature, and even deduce its incredible age. Spectroscopy allows us to look back in time, to understand the conditions of its birth. Early spectral readings from 3I Atlas suggest it contains water ice, carbon-based compounds, and volatile gases, similar to many comets native to our own system. However, variations in its dust patterns and the ratios of certain molecules hint that its chemical history is distinct, making it an extremely valuable research target. And then, the revelation. An astronomer with a mixture of exhaustion and exhilaration looks at the processed spectral data on a screen. Their eyes widen, a clear aha moment on their face. The data points to an origin in the Milky Way's thick disk. CGI depicts this region of our galaxy, a diffuse halo of ancient stars, older and more chaotic than our own quiet neighborhood in the thin disk. The thick disk contains about 10% of the Milky Way's stellar mass and is composed almost exclusively of stars older than 10 billion years. These stars are typically more metal-poor than those in our thin disk, suggesting a rapid formation early in the galaxy's history. A single powerful chord hangs in the air, a moment of silence before the scientist speaks, full of awe. The chemical signature was ancient, older than any comet in our own solar system. This was not just a piece of another star system. It was a piece of an elder star system, one that was born, lived, and possibly died long before Earth had even cooled. This was a relic from a lost galaxy within our own. Think of it, an object forged in a primordial stellar nursery, ejected into the vast emptiness, and now, after billions of years, it has found its way to us. Its very existence challenges our understanding of planetary system formation and the dynamics of galactic evolution. The fact that 3I Atlas exhibits a blue color shift as it neared the Sun, a surprising brightening, and even the detection of nickel vapor at an unexpected distance only deepens its mystique. Its gas plume shows a high nickel-to-cyanide ratio with very low water content, just 4%, which is an unusual composition for known comets. These unexpected chemical ratios and behaviors suggest that 3I Atlas's ancient formation and extraordinary flight through interstellar space have molded it with characteristics unlike anything orbiting the Sun. This cosmic traveler serves as a profound reminder of the dynamic nature of our galaxy. Star systems, like our own, are not isolated islands, but are constantly exchanging material. The gravitational interactions of giant planets are powerful enough to fling planetesimals into interstellar space, creating these celestial nomads. The very atoms within 3I Atlas tell a story of a different epoch, a different chemical environment. Its composition could offer insights into how interstellar comets contribute to star and planet formation throughout the galaxy. The arrival of 3I Atlas, the third confirmed interstellar object, along with Oumuamua and Borisov, marks the dawn of a new era in astronomy. With upcoming observatories like the Vera C. Rubin Observatory, designed to survey the southern hemisphere's sky with unprecedented precision, we expect to discover many more such objects. Scientists anticipate that the Vera C. Rubin Observatory could uncover around 100 interstellar objects annually, providing deeper insights into these enigmatic visitors from beyond our solar system. These future discoveries will not only enrich our understanding of other star systems, but also deepen our knowledge of the Milky Way's history. They compel us to ask, how many more ancient messages are hurtling through the cosmic dark, awaiting our discovery? And what forgotten chapters of galactic history do they carry? And what forgotten chapters of galactic history do they carry? It's a question that echoes through the vast, silent reaches of space, a whisper carried on the solar wind, until sometimes that whisper becomes a scream. For a brief, precious window, 3I Atlas offered us a glimpse into those forgotten chapters, a chance to read an ancient script written in ice and dust. But as it drew closer to the heart of our own star system, this messenger from another star began to behave in ways that didn't just defy expectation, they shattered it. Imagine, if you will, a cosmic magician stepping onto the grand stage of our solar system. The Sun is the blinding spotlight, casting its intense gaze upon a performer we thought we understood. This performer, a simple piece of rock and ice, is supposed to execute a predictable, well-rehearsed trick. As the heat intensifies, it should gently outgoss, forming a luminous, predictable tail, a celestial wisp, a familiar dance. That's the script we'd written, based on centuries of observing our own solar system's comets. But 3I Atlas, this ancient traveler, had no intention of following our script. Instead, it launched into an illusion so profound, so utterly baffling, that it turned the entire scientific community into a captivated, confused audience, debating furiously in the aisles. Was this a hidden mechanism, a trick of light and shadow we simply hadn't accounted for? Was it a fundamental flaw in our understanding of these cosmic wanderers, especially those born under distant suns? Or was it, perhaps, not a trick at all, but a revelation of something far more complex, far more active, and deeply, deeply puzzling than we could ever have imagined? The data streaming in from a network of observatories across our world, confirmed two bizarre concurrent events as 3I Atlas was preparing for its closest approach to the Sun. It wasn't just subtly deviating from the norm, it was screaming anomalies. First, a sudden massive increase in brightness, defying all models of cometary activity. It was as if someone had flicked a switch, turning a dim ember into a blazing beacon, and then a spectral shift, a dramatic change in its very essence, painting it in a distinct, ethereal blue. These weren't the gentle, gradual adjustments we expect from a celestial body interacting with solar radiation. These were dramatic, almost violent transformations, tearing holes in our neat, tidy models of cometary physics. You see, for weeks, our greatest instruments, our most powerful eyes on the cosmos, were effectively blind. 3I Atlas's trajectory was taking it directly behind the Sun. From Earth's perspective, a phenomenon astronomers call solar conjunction. It's a frustrating period of enforced blindness, a cosmic blackout where the sheer glare of our star renders even the most massive telescopes utterly useless. You knew it was there. This once-in-a-species object, this messenger from another star system, potentially the oldest comet ever observed, carrying secrets forged in the Milky Way's ancient thick disk. Billions of years ago, it was revealing its innermost workings to the Sun, exposing itself to intense heat and radiation. And you, the eager observer, were stuck waiting on the other side, helpless. The anticipation was palpable. A low hum of nervous energy rippling through observatories worldwide. Scientists, accustomed to the slow, deliberate pace of cosmic observation, found themselves caught in a tense, anticipatory silence. It's the worst feeling, one astronomer confessed, the frustration evident in their voice, knowing this once-in-a-species object is right there, revealing its secrets to the Sun, and you're stuck waiting on the other side. The music, tense and anticipatory, would underscore this feeling of helplessness, of being on the precipice of a discovery that was just out of reach. For what felt like an eternity, the Sun stood in the way, a blazing veil concealing the very object we yearned to understand. As 3I Atlas made its closest approach, it was hidden in that blinding glare, lost to our telescopes, to our probing eyes. Astronomers could only wait and wonder. What would the Sun's relentless heat and radiation do to this ancient traveler? This relic from a time before our own solar system was even a glimmer in the cosmic eye. No one, not a single soul, in the global scientific community was prepared for what came out the other side. Then, the alert. A sudden chime, a notification on a screen. A scientist, perhaps one who had been monitoring the data feeds with obsessive vigilance, pulls up the first new images, the first fresh spectral readings. The tension is almost unbearable. On the screen, a graph of the comet's brightness, its light curve appears. And there it is, a colossal, impossibly sharp spike, shooting upwards like a jolt of lightning, defying all models, all predictions. Simultaneously, the new spectral data loads, painting a dramatic, undeniable shift in color. The raw data, a chaotic symphony of numbers and lines, is then translated into beautiful, haunting visualizations. A glowing, incandescent blue object, unlike anything seen before. The camera would zoom in on the faces of the science team, their expressions a mixture of awe, disbelief, and profound shock. A sudden, sharp musical sting would cut through the silence, followed by a moment of stunned, reverent quiet. Then, the frantic typing begins, a flurry of fingers dancing across keyboards, punctuated by muttered disbelief. "That's not noise," someone whispers, voice barely audible. "That's the signal." It was brighter, impossibly brighter. Not a gradual, gentle increase, but a violent, almost instantaneous eruption of light, as if an internal furnace had been suddenly ignited. And it was blue, a deep, ethereal blue, a color that had no easy explanation for a comet. Comets are typically reddish, reflecting the organic compounds and dust that make up their surfaces, or they appear a neutral gray. This was something else entirely. This was the first undeniable clue, a cosmic fingerprint, screaming out for interpretation. But the mystery, as all truly profound mysteries do, only deepened with further analysis. Clue number 2 emerged from the intricate patterns of the comet's spectra, those unique fingerprints of light that tell us about an object's chemical composition. An animated graphic would illustrate the scientific principle. Elements like nickel, heavy metals, typically require immense heat to vaporize. They should only sublimate, turning directly from solid to gas, when they are practically skimming the surface of a star, where temperatures reach thousands of degrees. Yet, the data clearly showed a distinct nickel signature, not in dust, but as a vapor radiating from 3I Atlas. And here's the impossible part. 3I Atlas was still hundreds of millions of kilometers away from the Sun, a distance where nickel should have been frozen solid, locked immovably within its ancient icy core. We would see scientists gathered around a whiteboard, their faces etched with concentration, scrawling equations, drawing diagrams, trying desperately to model a scenario that could explain this profound anomaly. They couldn't. The music would shift, becoming a low, persistent, questioning drone, a sonic representation of the scientific mind grappling with the inexplicable. And the mystery compounded. Deep within that incandescent blue glow, those spectral fingerprints revealed not just an anomaly, but an impossibility. Nickel, not merely present, but in a gaseous state. This was a heavy metal, an element that demands scorching temperatures to be released from its solid form. For a comet to be sublimating nickel at such a vast distance from the Sun, it would require an internal heating mechanism, an energy source, or a structural composition that defied every known principle of cometary physics. The ghost in the machine was no longer a subtle whisper. It was a loud, undeniable presence, getting harder and harder to ignore. What could possibly be driving such an extreme reaction from an object supposedly made of primitive ice and rock? An object that had traveled for billions of years through the cold vacuum of interstellar space. We had seen comets surprise us before, humbling our scientific arrogance with their unpredictable nature. You might remember or have read about the real comet, C 2019 Y4 Atlas, a namesake that briefly captured the world's imagination in early 2020. It was discovered on December 28, 2019, by the Atlas survey in Hawaii, initially appearing as an incredibly faint smudge, barely magnitude 19.6. But then, between February and March 2020, something extraordinary happened. Its brightness increased an astonishing 4,000-fold, transforming it from an invisible speck to a relatively bright magnitude 8 object. Predictions soared, suggesting it could become a dazzling spectacle, potentially as bright as Venus, a comet of a generation, visible to the naked eye. The media buzzed with excitement, and stargazers around the world anticipated a celestial show. But the universe, as it often does, had a different plan. In late March and early April 2020, the narrative shifted dramatically from eager anticipation to profound mystery. C 2019 Y4 Atlas unexpectedly stopped brightening, then began to fade, contrary to all the sophisticated models astronomers had developed. The first crucial confirmation of its demise didn't come from a massive, publicly funded observatory, but from an amateur astronomer, José de Queiroz, who, on April 11, 2020, captured photographic evidence of multiple distinct fragments. The Hubble Space Telescope then provided the sharpest views, capturing up to 30 distinct fragments on April 20, 2020, and 25 just 3 days later. David Jewett, a lead astronomer on one of the Hubble observing teams at UCLA, famously described the chaotic procession of tumbling fragments as twinkling lights on a Christmas tree. Kwanji Yoi, another lead astronomer from the University of Maryland, noted the weird and unusual nature of its breakup, far from the Sun. This was a catastrophic disintegration, a comet literally crumbling into dozens of house-sized pieces, not when it was closest to the Sun, but while it was still over 91 million miles, 146 million kilometers from Earth. The primary mystery then, as it is, with 3I Atlas now, was why. Why did it disintegrate so far from the Sun, where solar heating is relatively weak? Theories emerged, attempting to explain this unexpected self-destruction. Perhaps the nucleus, no larger than the length of 2 football fields, was spinning itself apart due to powerful, uneven jets of outgassing ice. Or maybe it was the runaway sublimation of highly volatile ices hidden beneath its surface, creating internal pressures that tore it asunder. This dramatic breakup, a cometary funeral procession, as some called it, provided an unprecedented high-resolution view into the death of a comet, revealing that such fragmentation may, in fact, be the dominant way these icy wanderers meet their end, a process usually too quick and unpredictable to observe. The orbital path of C 2019 Y4 Atlas itself added another layer to the enigma. It was found to be nearly identical to that of the Great Comet of 1844, suggesting both were fragments of a much larger parent comet that had broken apart during a previous pass around the Sun some 5,000 years ago. This ancestral connection deepened the puzzle. If C 2019 Y4 Atlas was so fragile, how did its larger progenitor survive its last, much closer journey around the Sun thousands of years ago? It implied a complex, non-uniform interior for the original parent body, a hidden weakness that only revealed itself millennia later. The comet C 2019 Y4 Atlas was a lesson in humility for us, a stark reminder that even the normal comets of our own solar system are profoundly unpredictable. It was a spectacular failure, a promised celestial performance that ended in a tragic, premature disintegration. But 3I Atlas, our interstellar visitor, wasn't falling apart. It was doing something far more startling, far more unsettling to our established understanding. It was turning on. It was igniting, blazing with an impossible blue light, exhaling heavy metals at distances where they should remain locked in eternal ice. It was as if this ancient relic, this cosmic time capsule from the Milky Way's distant past, had absorbed the Sun's energy and, instead of crumbling, had begun to activate, to transform, to reveal a hidden, deeply complex character. This profound unpredictability, this ghost in the machine, forces us to confront the limits of our knowledge. What internal processes, what extraordinary composition, what unique history could allow an object, born 7 billion years ago, in the thick disk of our galaxy, to behave in such a bizarre, energetic fashion? Is it a glimpse into the raw, untamed physics of another star system? A chemical signature unlike anything forged in our own? Or are we witnessing a phenomenon that transcends our current understanding of cometary evolution entirely, hinting at forces or compositions we haven't even begun to theorize? The blue light and the nickel vapor are not just curious anomalies. They are direct challenges to our models, compelling us to ask, what incredible power source, what unexpected chemical reaction, what profound secret is 3I Atlas holding within its ancient heart, waiting to be revealed? says what incredible power source, what unexpected chemical reaction, what profound secret is 3i Atlas holding within its ancient heart, waiting to be revealed? When the universe whispers such profound enigmas, when the conventional explanations begin to fray at the edges, the very bedrock of scientific inquiry demands a shift in perspective. It requires us to step beyond the comfortable confines of known physics and venture into the realm of the extraordinary. This isn't about abandoning rigor. It's about embracing it with a broader, more imaginative lens. You see, the scientific method, at its heart, is a relentless pursuit of truth, an adversarial process where every piece of evidence is laid bare, scrutinized, and debated. It's a courtroom, if you will, where the universe itself presents the case, and humanity, with all its tools and intellect, serves as both the jury and the prosecuting and defense attorneys. And as the data from 3i Atlas continued to baffle the astronomical community, as the anomalies piled up, pushing the limits of our models, a vacuum of understanding began to form. Into this void, a voice emerged that was both celebrated for its intellectual courage and, at times, controversial for its provocative conclusions. This was the voice of Harvard astronomer Avi Loeb. Imagine yourself in the grand courtroom of science, the flickering holographic projections of 3i Atlas swirling around you, each strange behavior a piece of evidence. Avi Loeb steps forward, not as a believer, but as a charismatic prosecutor, building a circumstantial yet compelling case for an artificial origin. He's surrounded by books in his office, or perhaps you see him at a lectern, his gaze intense, his arguments precise. He's no stranger to this intellectual frontier, having famously engaged with the mysteries of Oumuamua, the first interstellar visitor, priming both the scientific community and the public for this very line of inquiry. The stage is set for a dramatic exploration of the boundaries of our knowledge, accompanied by a new musical theme, less about cosmic awe, more about the thrilling intrigue of intellectual discovery. Loeb begins, connecting the dots of 3i Atlas's inexplicable behavior with a logic that, while radical, is strikingly parsimonious. He points to the sudden, dramatic brightening of the object as it neared the sun. You remember how C 2019 Y4 Atlas, a long-period comet from our own solar system, also underwent an unexpected surge in brightness, increasing 4,000-fold from magnitude 17 to magnitude 8 in a short span between February and March 2020, leading to initial predictions of it becoming a spectacularly bright, naked-eye object. While that was a different comet, the phenomenon charts of rapid, intense brightening in interstellar object 3i Atlas was equally perplexing, defying conventional cometary models that struggle to account for such an energetic display from an object estimated to be billions of years old. Loeb's argument, presented with clean, compelling graphics, visualizes this brightening not as a chaotic outgassing event, but as a deliberate maneuver. What if, he proposes, this wasn't ice sublimating, but a vast reflective structure, a solar sail, reorienting itself to catch the sun's light, perhaps for propulsion or power? He gestures to the astonishing observation of 3i Atlas, turning a distinct blue as it passed behind the sun, a color shift that baffled observers. This isn't the chaotic, dusty plume of a typical comet, he suggests. Instead, he offers a hypothesis. The blue color could be the signature dose of an exotic, perhaps incredibly durable, material, designed to withstand the rigors of interstellar travel and solar radiation. Imagine a surface engineered not just for reflection, but for specific spectral properties that manifest as this uncanny blue. And then, there's the nickel vapor. You recall the astonishing detection of nickel vapor at a surprisingly large distance from the sun, far beyond where astronomers expected such a heavy metal to vaporize. This wasn't a fleeting glimpse. It was a persistent signature that defied easy explanation. Loeb's hypothesis, radical yet simple, links this anomaly to the very mechanics of a technological object. The nickel, he posits, could be a byproduct of an exotic engine, a residue of maneuvering thrusters, or perhaps even a component of the object's surface composition, slowly eroding as it navigates our solar system. He envisions an artifact, a piece of technology from another civilization, meticulously designed to traverse the vast emptiness between stars. What if 3I Atlas wasn't a comet at all? Loeb's voice, whether a real interview or a compelling actor's portrayal, cuts through the complexity. What if it was an artifact, a piece of technology from another civilization? He argues that while any single anomaly, the brightening, the blue color, the nickel vapor, could perhaps be explained away by some new, hitherto unknown natural phenomenon, the combination of them, the synchronous strangeness, pointed towards something more deliberate. He's not saying it is aliens. He's saying the most conservative explanation is the one that accounts for all the data. If a natural explanation requires us to invent 5 new unrelated types of cometary physics, while an artificial one explains all 5 anomalies with a single hypothesis, which is truly more parsimonious. This reframes the entire debate, shifting it from a sensationalist question of aliens to a legitimate, rigorous question of scientific methodology, forcing you, the audience, to grapple with the very logic of discovery. But for every extraordinary claim, the scientific community demands extraordinary evidence. The mainstream astronomers, representing the defense in this cosmic courtroom, calmly and respectfully present their counter-arguments. They are not dismissive. They are methodical, grounded in decades of observational data and theoretical models. Scientists like Quanji Ye, who has analyzed cometary behavior, or David Jewett, known for his work on distant solar system objects, step forward, not to refute Loeb out of hand, but to offer plausible, natural, though sometimes complex, counter-arguments for each piece of evidence. The rapid brightening, they argue, could be a runaway sublimation event. Imagine a pocket of highly volatile ice, perhaps trapped deep within the ancient, billions of years old nucleus of 3I Atlas, suddenly exposed. As it approaches the sun, this ice doesn't just gently sublimate. It flash explodes, creating a sudden dramatic surge in brightness. You saw how the long-period comet C219Y4 Atlas was theorized to have spun itself apart due to jets of outgassing ice or the runaway sublimation of volatile ices beneath its surface, even though it was significantly farther from the sun than expected for such an event. While 3I Atlas didn't disintegrate, like the 2019Y4 Atlas, the concept of runaway sublimation provides a natural mechanism for its extreme brightening. The mysterious blue color they counter could be due to unique diatomic carbon molecules, C2, which are known to emit blue-green light when energized by solar radiation. This is a common, albeit sometimes faint, signature in cometary comas. But perhaps 3I Atlas, with its unique interstellar composition and ancient origins from the Milky Way's thick disk of ancient stars, possesses an unusually high concentration of these molecules, leading to a more pronounced blue hue. It's a strange phenomenon, yes, but one rooted in known cometary chemistry, albeit at an unusual intensity. And the nickel vapor? That, they suggest, could simply come from a strange metal-rich composition we've never seen before. After all, 3I Atlas is only the third known interstellar object detected passing through our solar system, a messenger from another star system with potentially billions of years of cosmic history. It could carry chemical clues from the early Milky Way, materials forged in environments vastly different from our own. Perhaps its nucleus is permeated with pockets of nickel-bearing silicates, or even pure metallic nickel, released through some unknown process as it warms. Mike Meyer, an amateur astronomer, famously pointed out orbital similarities for another comet, highlighting the deep connections across celestial objects. The scientific establishment, with figures like José de Queiroz, an amateur astronomer whose keen eye first confirmed the fragmentation of another Atlas comet, and the sharp observations from the Hubble Space Telescope, which provided unprecedented views of cometary behavior, continue to gather data and refine these natural explanations. The music softens, becoming more balanced, emphasizing that this is not a conflict of personalities, but a proper, rigorous debate. It's the scientific method playing out in real time. Mainstream astronomers pushed back, not with dogma, but with data, models, and a deep understanding of cometary physics. They argued that while 3I Atlas was certainly strange, an ancient relic, potentially 7 billion years old, carrying the secrets of the early universe, strange does not automatically mean artificial. It could simply mean new, a phenomenon we haven't yet encountered or fully understood within the vast, diverse tapestry of natural cosmic processes. The screen splits, showing Avi Loeb on one side, his thoughtful expression reflecting the challenge he poses, and his critics on the other, their faces conveying the deep analysis required. This isn't a battle between right and wrong. It is the scientific method playing out in real time. On the grandest possible stage, you are reminded of historical examples of scientific debates. The initial skepticism surrounding continental drift, the counterintuitive revelations of quantum mechanics. These were not easy battles, but through rigorous argument, empirical evidence, and refinement, our understanding of the universe deepened. The visuals emphasize that science is not a static book of facts, but a dynamic, evolving process of argument, evidence, and refinement. A thoughtful, melodic score underscores this profound truth. The purpose of a hypothesis like Loeb's is not necessarily to be right, but to force the community to rigorously prove it wrong. And in doing so, to uncover a deeper, more accurate truth. It pushes the boundaries of our knowledge, compelling us to consider every possibility, no matter how remote. This interstellar visitor, 3I Atlas, is a unique opportunity. It's on a hyperbolic trajectory, meaning it will never return to our solar system, making every observation precious and dramatic. Its fleeting glimpse through our cosmic neighborhood is a rare chance to study an object that potentially predates our own solar system, a tangible connection to star systems beyond our own. The debate surrounding it, the clash of ideas, is precisely what fuels discovery. It's why observatories like the Vera C. Rubin Observatory are being built, expected to discover many more interstellar objects in the coming years, positioning the 3I Atlas story not as an isolated event, but as the dawn of a new era of interstellar astronomy. We are forced to ask fundamental questions. What constitutes extraordinary evidence? How do we distinguish between the truly inexplicable and merely the currently unexplained? And what does it mean for our place in the cosmos if the most parsimonious explanation for 3I Atlas's bizarre behavior is indeed a deliberate design? The search for technosignatures, those indicators of advanced technology, is an ongoing endeavor. A quiet whisper in the vast silence of the universe, connected to the Fermi paradox and the enduring question of the great silence. 3I Atlas, whatever its ultimate nature, has forced us to confront these questions head-on, to sharpen our tools of inquiry, and to expand the very horizons of our imagination. So, as 3I Atlas continues its silent, lonely journey back into the interstellar void, leaving behind only its enigmatic data, the debate continues. Is it a natural marvel, pushing the limits of our understanding of cometary physics, A true ancient relic carrying the secrets of star formation from billions of years ago? Or is it something else entirely? A silent ancient sentinel, a deliberate design, reminding us that we are but new arrivals on the cosmic stage, with so much left to learn about the vast unknown intelligence that might populate the universe. The implications of either answer are staggering, reshaping our cosmic narrative in profound ways. As we stand at this precipice of discovery, grappling with the profound mysteries that interstellar visitors like 3i Atlas present. What deeper truths about the universe, and indeed about ourselves, are we truly on the verge of uncovering? If you've been captivated by this journey into the unknown, if the celestial enigmas of our universe spark your curiosity, then join our growing community of cosmic explorers. Subscribe to Celestial Enigmas for more deep dives into the universe's most profound secrets. Thank you for being a part of this incredible adventure. We have looked at 3i Atlas, this singular enigmatic visitor, and in its fleeting passage, we've glimpsed something utterly profound. Was it a true ancient relic, carrying the secrets of star formation from billions of years ago? Or is it something else entirely? A silent ancient sentinel, a deliberate design, reminding us that we are but new arrivals on the cosmic stage, with so much left to learn about the vast unknown intelligence that might populate the universe. The implications of either answer are staggering, reshaping our cosmic narrative in profound ways. As we stand at this precipice of discovery, grappling with the profound mysteries that interstellar visitors like 3i Atlas present. What deeper truths about the universe, and indeed about ourselves, are we truly on the verge of uncovering? If you've been captivated by this journey into the unknown, if the celestial enigmas of our universe spark your curiosity, then join our growing community of cosmic explorers. Subscribe to Celestial Enigmas for more deep dives into the universe's most profound secrets. Thank you for being a part of this incredible adventure. The truth is, 3i Atlas, much like its predecessors Oumuamua and Borisov, is not an isolated oddity, a mere cosmic coincidence. These aren't just fascinating one-off events that punctuate the long, slow rhythm of astronomical discovery. No, what we've witnessed with these interstellar wanderers is far more significant. They are, in fact, the first drops of rain before a storm, the inaugural whispers of a coming wave that promises to redefine our place in the galaxy. The story is expanding, shifting from the painstaking tracking of a single bewildering object to the thrilling preparation for an entirely new era of interstellar astronomy, where these unexpected visitors from other star systems will become a regular, transformative part of our cosmic landscape. For all of human history, our view of the cosmos has been akin to peering through a tiny keyhole. We've been limited to observing what was immediately in front of us, what our relatively modest instruments could resolve, or what serendipitously announced its presence. But that era of accidental discovery, of isolated anomalies, is now drawing to a close. New observatories, like the colossal Vera C. Rubin Observatory, are not simply offering us a slightly bigger keyhole. They are the key itself, poised to unlock the floodgates of galactic traffic. The handful of interstellar visitors we've seen so far, these three confirmed objects, Oumuamua, Borisov, and most recently 3i Atlas, are merely the first trickle. Soon, a torrent of data on these objects will pour in, and our entire understanding of the galaxy's intricate network of celestial travelers will be rewritten. Imagine a star field stretching into the infinite, filled with countless points of light. Now, envision a simulation brought to life by the Vera C. Rubin Observatory team. On a vast screen, the projected discovery rate flickers into view, and the numbers are breathtaking. Not one interstellar object every few years, as has been our experience. No, The simulation projects potentially dozens, perhaps even hundreds, of these cosmic wayfarers discovered per year. The sheer volume is overwhelming, yet exhilarating. In this moment, the audience realizes that this entire documentary, which has meticulously focused on the mysteries of one object, 3i Atlas, is merely a prologue. The real story, the statistical study of entire populations of interstellar objects, the mapping of the galaxy's currents, the understanding of its vast unseen traffic, is about to begin. It's a radical shift from chasing individual ghosts to charting an entire ocean. On a remote mountaintop in Chile, a new eye on the sky is preparing to open, a marvel of engineering designed to capture the universe in an unprecedented way. The Vera C. Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, is nearing completion. Stunning visuals sweep across the screen. Time lapses show its massive dome rising against the stark, beautiful Chilean landscape. Its construction, a testament to human ingenuity and ambition. Animations illustrate the sheer scale of its components. An 8.4-meter primary mirror and a 3.2 gigapixel camera, the largest digital camera ever built for astronomy. Graphics glow with light, demonstrating its incredible field of view, capable of capturing an area of the sky as large as 45 full moons in a single shot. This monumental instrument will systematically scan the entire southern sky every few nights, creating a dynamic 10-year movie of the universe. An uplifting, forward-looking musical score swells, reflecting the immense hope and anticipation surrounding this new era. The era of accidental discovery, of waiting for chance encounters, is ending. The Vera C. Rubin Observatory, poised to begin its legacy survey of space and time later in 2025, is designed not just to look at specific targets, but to capture the entire night sky in a continuous, flowing motion picture. It will generate an astonishing 20 terabytes of data every single night, and it will change everything we thought we knew about the visitors from beyond our solar system. Consider an astronomer standing in front of a massive screen, which currently displays a simulated star field. Calm, predictable, familiar. With a gesture, they trigger a new simulation. Suddenly, dozens, then hundreds, then thousands of hyperbolic tracks begin to slash across the screen, each representing a unique interstellar object. The visual is overwhelming, powerful, a dizzying dance of cosmic travelers, each on its own unrepeatable journey through our solar system. This is the future, a future where we move from anomaly to statistics. An interview with a Vera Rubin scientist brings this future into sharp focus. We're going to go from a sample size of 3, Oumuamua, Borisov, and 3i Atlas, to a sample size of hundreds, maybe thousands, she explains, her voice alight with the thrill of impending discovery. We'll be able to ask questions we couldn't dream of before. Are they all weird? Or was Oumuamua the odd one out with its strange non-cometary behavior? Do they all come from specific directions in the galaxy, perhaps flung from the gravitational dance of a binary star system, or from regions of intense star formation? Are they primarily icy comets, like Borisov and 3i Atlas, or are rocky asteroids like Oumuamua more common? The data from Rubin will offer unprecedented insights into the properties, origins, and distribution of these objects, allowing us to statistically analyze what they are made of and where they come from. With this coming wave of discoveries, interstellar objects will transform from being mere curiosities, fleeting specters in our cosmic neighborhood, to being a vibrant, dynamic new field of astronomy. We will be able to map the subtle, unseen currents of the interstellar ocean, charting the pathways these objects take as they drift between star systems. We will begin to see what other solar systems are truly made of, sampling their ejected building blocks, and in doing so, we will gain a profound understanding of how common or rare our own home, our own unique planetary system, might truly be in the grand tapestry of the Milky Way. This influx of knowledge will allow us to test theories about planet formation in distant systems, providing direct evidence of processes happening light years away. But we aren't just planning to watch from afar, content with cataloging these distant visitors. We are planning a greeting. High-quality animation brings to life the European Space Agency's ambitious Comet Interceptor mission. We see the sleek three-part spacecraft, a marvel of compact engineering, waiting patiently at the Sun-Earth L2 Lagrange point, a gravitationally stable parking spot millions of kilometers from Earth. The animation shows it in a state of quiet readiness, its instruments dormant, conserving energy. Then, an alert flashes. A new interstellar object, or perhaps a pristine long-period comet, has been detected by ground-based surveys like Rubin, and its trajectory is a perfect match. The spacecraft fires its thrusters, a burst of energy propelling it from its waiting station. Beginning a meticulously calculated journey, we follow one of its probes as it separates, a smaller craft designed for a close encounter. For the first time, we will not just track these messengers, we will meet one of them up close, flying by to capture a 3D profile, analyzing its composition, structure, and coma. Exciting, propulsive music underscores the animation, conveying the daring spirit of this mission. The Comet Interceptor, planned for launch in 2029, is an ambush predator of the cosmos, designed to lie in wait for the perfect target. A pristine comet, entering the inner solar system for the first time. Or even better, a visitor like 3I Atlas, an object born around another star. It is our first tangible step off the shoreline of Earth, a proactive journey into the open ocean of interstellar space to meet a traveler face to face. This mission will offer unparalleled insights into objects that have remained largely untouched since their formation, preserving clues about the conditions in other stellar nurseries or the primordial solar nebula of our own system. The scene broadens, expanding from the details of missions and observatories to grand cosmic concepts. Animations illustrate the panspermia hypothesis, the compelling yet still unproven idea that life itself, or at least its fundamental building blocks, could travel between star systems, carried on objects like comets and asteroids. We see organic molecules, complex carbon compounds, shielded within icy cometary nuclei, surviving the harsh vacuum of space, only to be delivered to nascent planets. Graphics depict the Fermi paradox, a profound and unsettling silence that echoes across a galaxy we now know is teeming with billions of planets, many of them potentially habitable. If life is so common, if the universe is so vast, where is everyone? Why haven't we found definitive evidence of advanced extraterrestrial civilizations? A profound philosophical score accompanies these visuals, inviting deep contemplation. These interstellar visitors, whether they are natural objects or, as some speculate, something more, force us to confront our most fundamental questions about life, its origins and its prevalence. Could objects like 3I Atlas indeed seed planets with the building blocks of life, a process now gaining renewed interest with discoveries of organic compounds in space and the resilience of microorganisms? And as we prepare to find hundreds, perhaps thousands more, of these natural objects, does the continued absence of any obvious technological ones, any clear techno-signatures in the cacophony of cosmic data, make the silence of the universe even louder? It's a silence that compels us to look harder, to listen more intently, and to reflect on our own unique existence in this vast, mysterious cosmos. And the questions persist, echoing in the vast, silent expanse that surrounds us. It's a silence that compels us to look harder, to listen more intently, and to reflect on our own unique existence in this vast, mysterious cosmos. Then, Atlas arrived, not with a bang but with a whisper, a faint smudge of light against the velvet black, discovered on December 28, 2019, by the diligent robotic gaze of the Atlas survey in Hawaii. Imagine it, a lone, unflagged ship, silently cutting through the cosmic ocean, its sails catching the light of a star system billions of miles away. This was Atlas, a solitary voyager on a journey spanning eons, a messenger from another star system. For a brief, dazzling period, between February and March 2020, this cosmic wanderer defied all expectations. Its brightness surged an astonishing 4,000-fold, transforming from a spectral magnitude 17 to a more discernible magnitude 8. Early predictions hinted that Atlas might become one of the brightest comets in decades. The anticipation was palpable, but then, the unexpected. Just as its brilliance seemed destined to peak, the comet began to fade, unexpectedly stopping its dramatic ascent in late March and early April 2020. The narrative shifted from excitement to profound mystery. Then came the unraveling, both literally and figuratively. The initial confirmation of this catastrophic breakup didn't come from a monolithic observatory, but from the keen eye of an amateur astronomer, José de Queiroz, who on April 11, 2020, captured photographic evidence of its nucleus shattering. Soon after, the Hubble Space Telescope provided unprecedented, high-resolution views, observing up to 30 distinct fragments on April 20th and 25 fragments on April 23rd. David Jewett eloquently described these unpredictable, tumbling pieces as twinkling lights on a Christmas tree, a poetic image for what was, in essence, a cometary funeral procession. The primary mystery was why Atlas disintegrated so far from the Sun, over 91 million miles, 146 million kilometers from Earth, where the Sun's heating effects are relatively weak. This premature demise challenged existing models of cometary behavior. Theories emerged. Perhaps its nucleus was spinning itself apart due to powerful jets of outgassing ice, or perhaps a runaway sublimation of volatile ices beneath its surface led to its undoing. Each explanation only deepened the sense of an object holding secrets. And then, there was the suggestion of its ancient lineage. Research revealed that Atlas's orbit was nearly identical to that of the Great Comet of 1844, leading to the hypothesis that both were fragments of a much larger parent comet that had broken apart some 5,000 years ago. This ancestral connection added another layer to the mystery. If Atlas was so fragile, how did its larger parent body survive its previous, much closer journey around the Sun millennia ago? This implied a complex, non-uniform interior for the original body. This inherent rarity made it a cosmic time capsule. It carried chemical clues from an era far removed from our own. The sudden brightening, the inexplicable blue shift, and even the detection of nickel vapor all fueled a profound curiosity. This is where the debate intensified. The involvement of Harvard astronomer Avi Loeb, who publicly speculated that some anomalous interstellar objects could be of artificial origin, introduced a compelling element. The very act of asking what if pushed us to scrutinize every piece of data. The challenges of tracking such a fleeting visitor were immense. Its passage behind the Sun caused significant data gaps, underscoring the vital importance of international collaboration between space agencies like NASA and ESA. The story of Atlas became a testament to global unity, but as its light dimmed and its fragments scattered, a new understanding began to dawn. The true significance of Atlas wasn't ultimately about definitive answers. Its true significance lay in what it represented and what it inspired within us. Its fleeting passage was a profound gift. Atlas was like a lone, unlabeled ship passing our lighthouse in the dead of night. We flashed our lights, we studied it. But soon, it vanished over the horizon. We are left on the shore with a renewed sense of the sheer vastness of the sea, a profound curiosity, and a burning, undeniable inspiration. The final philosophical turn, finding a definitive, singular answer, is no longer the most important outcome. The true discovery was not a piece of rock, but the global collaboration it ignited, the public wonder it stirred, and the vibrant scientific debate it fueled. How its brief, enigmatic stay fundamentally changed us. CGI sequence begins. We watch from a vast distance as Atlas, its faint blue glow now barely discernible, recedes from our solar system. It tumbles silently, a tiny speck of light, past the stately orbits of Saturn, then Neptune. The Sun, our magnificent star, shrinks to become just the brightest among countless others in the cosmic tapestry. The object continues its solitary journey, heading back into the infinite dark from which it came. It will never return to us. Its hyperbolic arc is a promise of forever, carrying it away from our gravitational embrace, back into the interstellar void. For a brief, precious moment, its multi-billion-year journey intersected with our own. A visual montage begins, a series of warm, human, and hopeful shots. We see people looking up at the night sky, the scientists from our film, gazing at the stars with a renewed sense of wonder. A child, eyes wide with awe, peering through a telescope. A classroom of students, their faces illuminated by screens. We may never know for sure what Atlas truly was. And perhaps, in the grand scheme of things, that's perfectly okay. It reminded me in the most profound way that the universe has no obligation to make sense to us. Its mysteries are its own. For a few months, the whole world was looking up together. We were all asking the same fundamental questions. That shared sense of wonder, that collective curiosity. That's the part I'll always remember. It united us. Whether it was made of rock, or perhaps just perhaps, made by intelligence, it was a gift. It woke us up. It made us look up, made us think, made us question everything we thought we knew. We never found out where the ancient mariner was truly going. We only know where it has been, here, with us, for a precious, fleeting moment. It brought no explicit message, but we received one nonetheless, a message whispered on the solar winds, that the shoreline of our understanding is wider than we ever thought possible, that the ocean of the cosmos is deeper than we ever dreamed, and that our own journey, the human journey to understand our place within it all, has only just begun. What other cosmic ships lie waiting, just beyond the horizon of our perception? What new mysteries will they bring, and how will they, in turn, change us? If you've been touched by the wonder of these celestial enigmas, remember to subscribe to Celestial Enigmas for more journeys into the profound mysteries of our universe.